So here we've got the Calculus 1 Did I Get This problem for section 3.6. It's the chain rule, but it's actually a very specialized way of using the chain rule. This way focuses on fundamental knowledge. It's less about the computational stuff that the textbook focuses on. So let me help you make the connection between the computational stuff that you know and the more theoretical approach this takes. So let me remind you, right? If you were asked to take the derivative of, and then let's make it something that's sine, the outside function, the first function, and then let's make it x squared on the inside. Derivative of sine, that's one function, of something else, that's a function, right? What I'm trying to do here is make the connection f of g of x, right? Sine is the f, and x squared is the g of x. Well, when we do the derivative of sine of x squared, if you've gotten proficiency with the, let's call it the algebraic approach, right? The answer would be pretty simple. It's not meant to be hard, right? You take the derivative of the sine is cosine. You applied to x squared, right? You don't change the thing on the inside. You change the outside. Sine became cosine because you took the derivative of sine. You apply it to the x squared, but then multiply by the chain term, right? There's always that chain term at the end. Why? Because we didn't have plain old x, right? If it was sine of x, we would have stopped. There's no need to chain because x is just x. But it's x squared, so we need to multiply by the chain term of the derivative of the inside function. And that, of course, is 2x. The derivative of x squared is 2x. So the answer is cosine, still plain old x squared. That doesn't get affected, but we multiply that by 2x at the end. Usually what we do for clarity is we put the coefficients, the multipliers, up in the front, because if you have them dangling at the end, it's sort of, is that inside the cosine parentheses or not inside the cosine parentheses? It really isn't. So multiplication, you can put it wherever you want. So there it is. So remember that, right? Derivative of the outside applied to the old inside, but multiply by the chain term of the derivative of the inside. So that's exactly how we find h prime, right? H is made of two functions. So h prime, the derivative of h, well, h is made of two functions, right? There's the outside function, and like before, we have to take the derivative of the outside function. There it is, f prime. And we apply it to the old function without changing it, right? That's just like leaving x squared alone. And then we have to multiply by the chain term, right? There's that correction factor of the chain term. And the chain term is the derivative of that inside function, right? It was 2x here in the computational example. So it's just g prime of x here. And that's really all we need to do. Everything else is going to fall right out of that computation right there. This is, in fact, I'm going to make that a nice big size font because that's really important. Without that, you're not going to get anywhere. So they asked for h prime of 1. All the rest is just doing function stuff, right? So h prime of 1, oh, okay. They want x to be 1. So now we just compute it, right? F prime of g of 1. And then we're supposed to multiply by g prime of 1, right? No big deal. This is all table lookup stuff. So we start working the table, right? Let's see. F prime of G of 1. Oop, lost a parentheses. F prime of G of 1. Well, I mean, F prime of G of 1, but what's G of 1? G of 1 comes from the table, right? We need G of 1. So we need this value here. Oops, sorry. We need this value here. G of 1 is 3. So the G of 1 is 3, so we put that in. And let's do another table lookup. G prime of 1. Oh, we're still in the 1 column because we're evaluating at 1, but we need to know G prime of 1 because that was the chain term, the derivative term. So where's that? Well, let's take a look at the table. It's G prime of 1, so we look in the 1 column for G prime of x, and that's 4. I'll circle it, right? G prime of 1 is 4. And then looks like we're going to be very close to the end here. The only remaining thing to compute is f prime of 3. So let's look at the table. F prime is the third row, of 3 is the third column. So it looks like we have a 2 there. So that would be 2 times 4. And of course, we compute that and get 8. What I'll do here is I'll double circle the second thing we used, and I'll triple circle the third thing we used. So you can kind of see from the visuals what's going on. This is the first computation. This is the second computation. Sorry, this is the first computation, finding G of 1. Finding G prime of 1 was our second computation. Let me correct my slight errors here. The first computation was finding that G of 1 is 3. The second computation was finding that G prime of 1 is 4. And the third computation was finding that F prime of 3 is 2. So G of 1, right? And then F prime is 2. And this one is G prime of 1 is 4. So those are our 3 computations. 1, 2, and 3. That's how you're going to deal with it on the pre-assessment and the exam. They'll give you some table. They'll tell you that here's a relationship between 3 functions. It might be H, F, and G. It could be 3 completely different letters. And you'll need to know, and I'll emphasize it again, this is what you need to know how to do. You need to know how to convert this abstract functional notation and function of a function stuff above into this very practical formula. And it really does follow how we should think of chain rule. You don't interfere with the inside in the first step. You just take the derivative of the outside. F is the outside function. And then you multiply by the derivative of the inside, right? The inside doesn't get touched when you're taking the derivative of the outside, but then you have to multiply by this correcting factor of the derivative of the inside. So it gets its derivative, but only afterwards as a multiplier at the end. So that's how you're going to be able to do just about any problem. They'll set it up so that if you do it right, you can still look up everything on the table.